Salam sejahtera and hello everyone. Welcome to the presentation from Group 2. This group is formed by the 6 members which are Mong Cheng Fu, Vanessa Tay, Nodiana, Li Wan Ting, Yan Peng and me, Lin Jing. This project is about the queue management of dental service in Pusat Kesehatan UTM, which is also known as PKU. First, this presentation will start with the introduction and discuss about the problem statement, objective, and assumption in our study. Then, we will investigate the background of UTM, PKU, and discuss about the data collection and how we conduct the analysis. Then, the result and discussion is presented about using the Simulate to simulate the queuing system in PKU. Finally, some conclusion is made at the end of this presentation. A queue is defined as a set of principles to control customer flow when they seek the service. Managing queue in dental clinics are important to avoid confusion of patient which counter they should go for the service. In PKU, dental services are available for university staff and students. The performance of the service might vary due to the number of dentists on duty. This study intends to recommend the best solution to PKU to optimize the queuing system in dental service.
Hello, my name is Nordiana. Now move to problem statement. Queue management is very important in many fields. However, not every customer pleased with the service offered, especially when they experience long waiting time. Then, they will easily justify how bad the service are. It is suggested to have a systematic queuing to solve the problem. Therefore, analyzation using mathematical simulation of the queuing system will be beneficial. Objective of this project are to estimate the queuing parameters and verify its distribution. Secondly, to simulate the queuing system in few scenarios at Dental Clinic of University Technology Malaysia. Next, to test the stability, efficiency and stability of the queuing models used, and lastly, to determine the best queuing model as a recommendation to the dental clinic. Proceed to assumptions. There are 4 assumptions. First, we use first come first served principle for queue display in this project. Second, there are 2 dentists as the servers in the system. Third, waiting room of the queue is limited finite number which is not more than 40 patients. And lastly, for the size of calling source for patients is finite which are restricted only for student and staff of University Technology Malaysia.
My name is Chayan Pen. Pusat Kesehatan UTM in Johor Bahru is chosen as our study healthcare institution, which is established in 1972 and has provided dental service to UTM students and staff since February 1994. However, students can get the dental service on working days, while staff can only get the service during student semester break and on Saturday's working week after office hours. For the model conceptualization, we have looked at 3 components to determine the study framework, which are customer arrivals, waiting time, and service time at dental clinic. The activity cycle diagram with only 2 entities, which are customer and counter, is then designed as shown below. In this study, we will only focus on the queue system from dental clinic at PKU, and the primary data on daily basis in April 2019 is obtained by email to the team ICT.
My name is Li Wan Ting. So this is the example data we obtained from PKU. As we can see in this slide, the data is differentiated into 2 servers, which are server 1 and server 2. The data obtained includes the queue number, register date, day, scan time, and calling time of the patients. The inter-arrival time is the difference between 2 patients' scan time. The service time is the difference between 2 patients' calling time, while the waiting time is the difference between the calling time and scan time. Next, the mean of operating characteristics includes inter-arrival time, waiting time, and service time of each server are shown in the table. In this project, we use chi-square goodness of fit test to determine the probability distribution of the inter-arrival time and service time. The null hypothesis is the data follows the exponential distribution, while the alternative hypothesis is the data does not follow the exponential distribution. So we will reject the null hypothesis if the test statistic is greater than the critical value. For the hypothesis testing results, both inter-arrival time and service time are follow the exponential distribution. This is because both test statistics value are smaller than the critical value. Now I will pass the presentation to my groupmate.
Hi everyone, this is Chong Fu presenting. Now I would like to demonstrate our schematic model. Our queuing model is MM2 in Cantor notation. As you can see, we have a work entry point with exponential distribution of average of 30.3908 minutes, and then to a queue of 40 capacity, to a registration counter as well with average distribution of 5 minutes, and to a queue again with 40 capacity. As you can see, we have two servers here with exponential distribution with 30.5828 minutes, and then go to an exit. Now we log on the clock properties. We have 6 days per week for our operation start at 8 a.m. and then we will work for 9 hours. So let's start our simulation. So as you can see, there is no error and there is no bottleneck for this model. Now I would like to show on how we work on our scenario experimentation. The first scenario is to add or reduce the server. So to reduce the server, we will just delete this server, and then this considered as single server. So we reset and run our result. So this will be the result for our single server. Then we will undo the delete object to remain to the default model. And to add, we will just control and drag. So this will be our 3 dentist model. And to reset and run. So this is the result for the 3 dentists as well. To expand the queue capacity, we will just click to the queue and then we will click to infinity queue. And then this as well to infinity queue. To set the last number of arrival, we will set our inter-arrival time to in the work entry point to 15.1976. And then we will just modify on here to 15.1976. That's all. Thank you. For now, we are going to review the result on our scenario experimentation. The first scenario is to add or reduce the number of dentists in the dental clinic. In this scenario, we have tested the system by using 2 dentists, 1 dentist, and 3 dentists. The results show that the model with 1 dentist has the greatest utilization, which is 93%, but the queuing time is more than 2 hours. And based on the single server diagram, you can see that there is a bottleneck in the queue, and then not all the arrivals have completed their service. The model with 3 dentists has the smallest average queuing time with 1.58 minutes, but the 73.3% of the time the servers are idle, and this may lead to higher cost of manpower. The model of 2 dentists is considered as optimal because this is due to more than 50% of utilization, and the average queuing time is lower than 30 minutes. The second scenario is that to expanding the queue size to infinity. Based on the table, we can see that there is no difference for the operating characteristic between the infinity queue and the limited queue of 40. And this is lead to not necessary to make any changes to the queue capacity as the performance of the system is not affected.
Hi, I'm Vanessa. The third scenario is large number of patient arrival. It can be observed that the default model with double arrival rate shows there is no bottleneck occur, while for the single server with double arrival rate shows there is fully bottleneck occur, as there are 196 patient arrival, but only 119 patients complete the dental services with utilization of 100%. For the 3 servers with double arrival rate shows there's no congested in queue, as the number of patient arrival is same with the number of patients that have been completed in the dental service, which is 211. And this model is outperformed with the lowest average service time and waiting time. In this study, the scenario of variety in number of dentists, infinity queue capacity, and double arrival rate are tested and simulated. To ensure the consistency and efficiency, the model with average utilization is higher than 50% is acceptable. Thus, the default model with 2 servers of 40 queue capacity is an optimal system, as it sustains all the critical situations with higher average utilization of 54% and lower average time in system of 51.22 minutes and waiting time of 17.01 minutes. That's all from our presentation. Thank you.